You feel me? Okay. So, who remembers what an alloy is from Unit 1? Okay, so two metals added together to make what?
Stronger.
So an optimized combo, something that's got some property that we want, some desirable product that we want, okay? And then my joke, if Iron Man and Silver Surfer teamed up, would they be alloys?
Like alloys.
Maybe alloy.
Thanks, Miss Enlow. You're so funny. Okay. Here's what you can put on the middle of your folder, okay? This is kind of the biggest piece of information, then we'll have some more pictures and stuff that you could always draw if you need to. You can write it word for word, or you can paraphrase. So I'm going to tell you some of the key points. First, we have covalent bonds and we have ionic bonds, and those are what we really do call bonds. This one is not an actual bond because it's more of just an attraction. But what other bond type is kind of just simply an attraction? Ionic or covalent? Attraction. What things attract people?
Opposites.
Opposites. Opposite what? Charges, right? So, you know, we say ionics are bonds, but they're really just attractions too. So people use the word bond and they think it's like, I'm holding on to you for life, right? It's not actually sometimes something that's physically connected. So this is kind of similar to an attraction, just like ionic bonds are. So an attraction because there's plus things that are positively charged, and there's things that are negatively charged. But those things are not the same thing exactly as an ionic compound. So what happens, I'll go over alloys again in a second. Basically, here's the picture. Aluminum. If I'm aluminum, how many electrons do I lose? You should be pros at this. It's 3. I'm hearing 3 a lot, right? Where's aluminum at? Aluminum is not a transition metal, people. It is group 3. So I'm going to point over here on, maybe on. Aluminum is right there. So it has 3 valence electrons because it's in group 3A. It can either lose 3 electrons, 1, 2, 3, bounce back to neon's electron configuration, or it can gain what? 1, 2, 3, 4, 5, right? Cinco. That's way too many electrons to gain, so it rather would lose. All metals lose electrons. Every single metal will. So it gains a 3+ charge, gets a 3+ charge because of its loss of electrons. But then there's these 3 electrons just hanging out, having a good old time, right? Well, that's going to happen times infinity. Okay, there's a ton of these that are doing this. So then there's just a bunch of cations. That's an infinity symbol right there. Then there's just a bunch of cations, and then these electrons hanging out. So you could do that over and over again. There's aluminum, 3 electrons hanging out. There's aluminum, 3 electrons hanging out. Eventually, this happens in such a large quantity, it makes a sea of electrons. A sea, like a bunch, a big pool of them. And that's where the attraction part comes in. So I'll continue with that in a second. This right here, kind of just did for warm-up, right? Is that new? Is that statement new? Not really. 2 different metals combined together, they alloy together. And one of the cool alloys, example, gallium, indium. Those are 2 really, really, really rare metals, but they use them in most of our cell phones. Okay, so it's what creates the contact. Whenever you touch your finger to it, it tells the phone kind of what to do from there, from the electrical contacts. So it's actually very conductive. It's actually more conductive than either one of them individually. So that's what they use it. So thank you, Lord, for some gallium indium alloy, because if not, our cell phones would not work. Okay, so what have I already said here? How metallic bonds work. What did we just kind of glean from our pictures? Anybody? Alex, what is our picture of up here? Our random electrons everywhere. Give me something.
Delocalized electrons?
Yeah, perfect. They're delocalized. What does it mean to be localized? Let's kind of cover that first. I am localized right here. I'm in one spot. I'm not going to move, right? You're in a set place. Delocalized means what?
You're free moving.
You're free moving. You're not in one spot. You can be in many, many locations. So delocalized means many locations are not in one specific location. And so that's why the electrons are kind of everywhere and they're able to move. So if I really wanted to show that, I Like I say, they're moving this way, and this way, and this way, so they're crazy, right? They're delocalized in a sea of electrons. And then here's that kind of picture again, where the aluminum cation had lost its valence electrons. So, recap. Metal bonds, are they really bonds? No, what are they mainly? Attractions between what and what? The metal cation and the what? Metal cation and what's positives attracted to, people?
Anions.
I know normally it is anions, but there's no anions in this picture. Electrons, right? So it's just simply the positive cation, which is the metal, like aluminum in this case, attracted to the sea of electrons it's literally surrounded by. So these free electrons that are able to move, they're called mobile electrons. They move a lot. What are some properties you can think of from metals that we kind of can relate to the mobility of their electrons? Malleability. What else? Malleable, ductile. What else? Luster doesn't. I think is not going to really tell us about its electrons. It's just actually the way it looks. One more. How does the internet work? Big question. Electrons flowing, right? What does it flow through?
This.
That thing. Yeah, I mean that's like kind of the thing. There's also like this wire thing. You guys have seen a wire? Yeah? It's got metals in it. Ethernet cord. We're getting some serious vocabulary. Okay. So electricity in general is movement of electrons, and internet works through the transition of that, but also energy too. But anyway, so I'm thinking conductivity. Something somebody would say. Conductivity. You guys are like Ethernet cords. Okay. So here's our picture again. Cation core, mobile electrons everywhere. Cation core, mobile electrons everywhere. So the last bit of information is just simply explaining those three properties, and then we'll talk about alloy examples. So you don't have to draw that. We kind of already drew that. Ooh, why is silver only losing one electron? It's not in group 1. Do you remember our couple of transition metals that have a standard charge? Like what? Like silver's number 1. Yeah? Silver's number 1. Okay. You have to know that. All right, so conductivity. We've got thermal conduction and electrical conduction. Basically, mobile electrons are the root cause of both of these properties. That's just one thing that you need to be aware of. And so whenever they're mobile, the electrons can carry charge and carry charge and pass it from place to place to place, and that allows for this flow. You guys okay? Getting everything pulled up? It's not connecting. My Wi-Fi in my room has been wishy-washy, so we'll get on the desktop soon. Okay, malleable and ductile. What does it mean to be malleable? Shout it out. Squish. Flatten into a sheet. Let's be specific here. Squish. Flatten into a sheet.
Squish factor.
And ductility means what? Okay, so we can pull into a wire. Okay, so the premise of why both of these work really, 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 really well with metals is that these electrons are mobile, right? And they're really tiny. They actually can, I'm going to kind of write this in a bracket for all of it, is the electrons move to fill gaps created by either one of these mechanical processes of either, hitting with the hammer, and eventually, if you hit something with a hammer enough, it's going to break, right? Metals, if you heat them up enough, that's not, it happens, but it's going to happen in an extreme case. They tend to continue to flatten out. So that's nice because the electrons are filling in to match the gaps so that it doesn't become brittle and doesn't break. Same thing with the wire. You can keep pulling it out, and it does have a breaking point eventually, but the electrons are going to fill in the gaps so it doesn't just break in half. So that's actually the electrons doing their job of filling in gaps. So again, this counters the ionic field of ionic, where's our crystal? Here it is. Where, if this green one is chlorine and this gray one is sodium, so this is sodium chloride, where are the electrons really hanging around? Sodium or chlorine? Who gains the electron? Raise your hand. Sodium. Chlorine. Majority rules. Okay. So chlorine, because fluoride gets the -1 charge because it's in group chlorine. 7. Yes. Okay, so it gets the -1 charge. So all the electrons are hanging out around that chlorine, that one, that one, that one, that one. It's localized on that specific atom or that ion. That's why we call that a static charge. The electrons are not mobile. So the electrons are stuck. Remember we talked about the stuck electrons on our first notes, dated notes. All right, so you've got metallic, ionic, and covalent. You feel good about the properties of those? Shake your heads, people. Yes, thank you. Okay, alloys. Last two, these are the only two examples I'm going to give you. So alloys we actually warmed up with, so we said that it has a desired property once you put the two metals together. So something is, you put them together for the purpose of making them both better. So sometimes two heads are better than one. You have something that's going to be benefiting us in some way or form in application. So we've all seen a cast iron skillet? Yeah?
Mm-hmm.
Who cooks with a cast iron skillet at home? Yeah? Okay. My husband does because, I can bake, but I don't know how to cook. So he uses this. And the reason we have a cast iron skillet is because after the iron and carbon come together, the iron, which is conductive, why is the iron conductive? Because it's a metal, okay? It's conductive to not only electricity, but also heat. So I'm going to put thermal conductivity there. Why is that beneficial if you're using it to cook? So you're just putting the pot on the stove and nothing's going to happen, right? So it needs to allow for the heat from the burner to come up through the metal to the food, and then the carbon part actually helps it maintain a high specific heat. Okay, so that actually allows for when they come together and maintain a high specific heat. Basically, what's that mean? What that means is that if you turn off the oven or turn off the stove, then the pot is going to stay hot for hours. It's going to stay on for a long time, so it holds the heat really, really well. So you don't have to keep the burner on forever. It'll just maintain, its warmness to whenever you want to eat. So these two things come together and make a useful product. Okay. This next one, bronze is not exactly useful, but who's been to Kidnapolis, K-Town? Dale Earnhardt, 3. You've seen the statue? Have you seen the statue? Okay, it's beautiful. Okay, in memory of NASCAR driver number 3. But they combine these two different metals. Copper, what's the color of copper? Okay, I was hoping someone would say copper. I'm like, yeah, okay. So brown, kind of red color, orangey. Tin it has a color, but it's I'm just going to say it's got some luster to it. But copper is incredibly unreactive, okay? They're non-reactive. Why do you think they build a statue out of tin and copper where copper is not reactive?
So it doesn't get copper rust.
Right, it doesn't rust. It doesn't react very well. So it doesn't get what?
Oh.
What were you saying?
Oh, like you won't get all.
It doesn't decay. It doesn't get ugly. It doesn't get patina on it like the Statue of Liberty. There are some ways that copper do react, but it's fairly unreactive. But it's actually more unreactive when it's bound up with tin. So it maintains its structure. Yeah. So that's actually. Oh, I didn't mean to do that. That's actually one of the key features of bronze is that it's not going to react as quickly as maybe silver or nickel. Okay, so that's alloys for you. We're actually going to make an alloy maybe tomorrow, so we'll see what we get to today. And here's our types of bonds, mobile electrons. So electrons go away whenever you hit them with a baseball bat. That's it. That's it for electrons. For metal bonds, metallic bonds. Just throw it on the floor. Okay, so here we go. Next is we are going to get 7 to 8 minutes to get ready for our skits. So wait a second, okay? You can get a Chromebook, you can get a desktop, but what we're going to do is you're going to get 7 minutes to get lined up for your skit. Make sure you have what you need, and then we're going to leave about 3 groups in here. So not 3 groups, 3 pairings. So like Madison's group can present to my group, I'm going to present to her group. We might be kind of loud, so we might go to the hallway, and if you are in your Jacob's group and
like right in front of the S3 office, so that way we're not disturbing any classes and people won't walk through out the
yeah. So you guys can go to the hallway too. But I'm just going to make sure that we're paired up so that people can video for each other. Remember the Wi-Fi in my room is kind of crappy, so you just gotta have to work with that. What Ms. Parker said is if you want to try to connect, either connect with just the Chromebook or just your phone, not both. Just apparently there's too many devices and people try to think can happen. But it's a thing. Okay? I'll do that later. So after that, we're going to act for 7 minutes. Somebody's going to video. Next group's going to act for 7 minutes in video. So we should be back in here in about 25 minutes. Yeah. I already have copies.
What if we like
If you edited it, I'll ask for another copy. Yes. So if you're with me, you're going to get started in 7 minutes. Go. Jack.
really?
Not Jack. Jack is L.
Did you think about ones? That was a stupid mistake. That's not a thing. Silicon dioxide.
Will you help a group?
Sure.
It's cool.
I checked up on this.
Can you like Jack in the future?
Okay.
So you're 7 minutes in your life.
Do you know who Regina George is? Okay. We should have watched it. I think you so big. You're her. Her.
They made crazy.
Okay,
Why am I her?
when you're literally a banana. It was perfect. I went to party.
Regina from Heroes. Oh, really?
Unless you want to hear it.
No, I mean,
He's like, I'll let Jack take it.
I think I have your number from you. Let's see if that's it.
Are you going to be in the quiz?
Why is he a banana?
They have the inflatable He's got like the scruff and everything going on. It's just like, come on.
Just come on, Rowan. He'll do it. Tell that one is the last one.
why can't I have a...
We don't have to.
They're gonna say for Halloween.
They're not as big as I thought they were.
I like
Thanks for running me up.
Alright, catch up. Yeah, go. I think your group got there.
Oh, I'm about to put my hair in listen.
We get a web word of
I'm gonna stop. I mean, at this
We're going to go ahead and school time, so I'm going to have you three present together. Okay? It'll be free. So one person, rock paper, scissors goes first. Cool. So you guys just make sure I get 3 videos. And I'll come in and out and check on you guys. Some of you guys need to start it now. Okay, get started now. You guys are fine.
I'll just switch my mind with it. Yeah, I'm gonna bring up that one. Hey, Jake. You want to use my PVC?
Yeah, we got exclamation.
Yeah, bring your PVC. Yeah, my PVC pipe. Beat someone to a pole.
Like, we're like 5 minutes.
Well, let's see what you can do. What? Look at this guy. Oh, nothing. Anyway, so at least have useful, right? Because we still get silicon dioxide. Silicon the formula, the previous subscripts for the silicon. Silicon assembly. There's no preface. We got that no preface. Which means that what silicon is to give us Si. Our formula, dioxide, sulfur oxide, everything else. So simple, it's the fixes the I means 2, so there are 2 atoms of oxygen. Then the second formula is O2 combining these 2 parts again. O2. So that's one. Let's keep it. Here we have 11 2 phosphide. formula for it. This is an ionic bond because it involves non-metal element. You also know that it's binary because it has two elements. Like it's like two charges shown by the Roman numerals of parentheses. Roman numerals of parentheses. Phosphorus. You might be trying. So here, phosphorus 1, 3.
I like the way you write your essay.
So, charges usually crisscross. Jump. Crisscross. We have formulas. The symbol is PB. We take 3 minus charge of phosphorus. The subscript from PB. 11 PB. Take up 2 plus charge. The subscript of phosphorus. The symbol is P. This gives us the formula PB3. P. 2.
I sure wish I paid attention to my chemistry main law.
It's okay. Just chemistry is an easy stuff. Like I said, I don't really know why you took this.
Well, I'm broke to move along with the virus. Anyways, let's get back to it. So I remember one thing that I recognized. Magnesium cyanide.
Oh, great. All right. Explain how to get the name of the formula.
We know that it's it has metal. There's metal in the line. It's turning because it is bound in a polyatomic concentrate. We know that magnesium
Nicely done. Alright, let me quiz you on our next piece. I'll catch the one for the nice try.
Should we just
And
set
you need
these
to write
up
down his name
and
and
just like
formula.
have them like this?
Explain that one to me.
Oh, yeah. Somehow remember how to do this one too.
Oh,
So, you know that PE is really, nitrite is basically liquid. Oh, these are the only 2 elements involved. So we know that this is a binary ionic bond.
okay.
These are the reverse crisscross. We take the subscript of these 2 elements and place it as charges. As the charges, but we see that the charge of these the charge of nitrogen is 3 elements. The charges are not influence or count. The first element is beryllium, so that element is first. And then the nitrogen right after it, they take beryllium and sodium. The second element, straight off the table, we have the side nitrogen. We have the nitrogen. Final product.
Oh, man, gosh, the grades just made it $5 a week. Just estimated use. Yeah, I'll take this next one. So we have calcium nitrate. We have to go from the formula to the name here. There are 3 elements, both metals and non-metals. This means that it is a ternary ionic compound. First, we have to know what it is we are working with. From the periodic table, we know that Ca is calcium, a metal. We also know that NO3 is a polyatomic ion. Using the reverse crisscross method, we take the subscript from NO3 and place it as the charge of Ca. The charge is 2 volts. Then we take the subscript of Ca and place it as the charge of NO3 because there is no subscript labeled. It is assuming the charge is positive. In this case, the charge is what? Minus. Now, that we know elements highly atomic ions we are dealing with, we can write the name. Ca goes first, and then is the name calcium. Calcium. No. There's a lot of notes there. Then we place NO3 nitrate at the calcium. This gives us calcium nitrate.
What's this last one?
Ah, good. Carbon tetrachloride. Let me show you how to do it. So it's named from the formula we have here. Before we can change the formula to the name, we have to know. I've been looking at these the whole time. Because we have to know what we are working on the periodic table. We see that C is carbon and Cl is chlorine. Because there is no subscript to C, there is only 1 atom of carbon. This means that the first part of the name is simply carbon. Carbon. The subscript for Cl is 4. This means that there are 4 atoms of chlorine. Because there are four atoms only, with the prefix, the word called. The prefix for four atoms is tetra, so the this is called tetrachloride. Ever since chlorine is a part of the periodic table, the end is suffix I. This means it is written as tetrachloride. Combining these two parts, we get carbon, tetrachloride. Ah, no problem.
One question.
Oh. Our best customer, Mr. McNeil.
I love that you got a script right in the middle.
You guys are getting ready to start.
Yeah, we're almost about to start.
You about to start the second one? Okay, I'm gonna go video another group because they're a little slow.
We haven't done.
Oh, you guys haven't done the first video?
No, we were waiting for them. We're almost
Or
there.
if you don't video today, we'll come back and video 32.
Okay, let's do it. Welcome to practice question. This exam will be a nomenclature for ionic and covalent compounds. Our first topic is ionic compounds for survival of strange. Ionic compounds can be either binary or ternary. Binary compounds are made by combining two elements from a periodic table. Try to remember the difference between the two is that bi means exclusive and then the binary compound is two elements. Ternary compounds contain one element and one strand of isomers.
I look at something you're looking at now.
Wait, I'm sorry. Are you doing this exam or yeah? Should I stay on this? Welcome to Science to Survive. Our second exam will be on nomenclature for ionic and covalent compounds. Our first topic is ionic compounds for survival of speech. Ionic compounds can be either binary or ternary. Binary compounds are made by combining two elements from a periodic table. Try to remember the difference between the two is that bi means exclusive and then the binary compound is two elements. Ternary compounds contain one element and one strand of in the case of bi and bi. Remember, when creating ionic compounds, the two elements usually emit a non-metal upon crossing the metal, where the metal gives the electrons to something else in the metal. With this, the element becomes charged either cation or anion. Then they become attracted to one another, therefore creating an ionic bond. Here are some examples. We start by creating hexene 4. Here we have one to represent calcium, which is the hexene 4. We combine the milk that has a charge of 2 plus and the toothpaste, which gains one more electron, making it overall liquid. When the milk and toothpaste bond, they create CaF2 because the ionic compound is covalent. Let's move on to another example. Let's say that now we have to create nickel 3 iodide. The nickel represents the element nickel, which has a charge of 3 plus, and iodide salt is used to represent iodine, which is the element iodide that has one negative charge. Let's cross them over to see what we get. Wow, we created NiI3. It's chemistry. compound we'll talk about. It's a big thing because it's found in fireworks. This compound in fireworks is written as KNO3 and contains polyatomic ion. We call this potassium nitrate. So potassium originally has a positive 1 charge, and nitrate has a polyatomic ion NO3 negative 1 charge. First class, these two charges take the formula KNO3. This means more nitrate is needed to combine with one potassium ion to make it neutral. So now we know how to create fireworks. C is a chemistry fun. Our last ternary ionic compound has the formula NaOH. Let's try sodium table salt in this example with hydroxide, which is a perfect compound. It's base has a high pH. Both compounds combine with sodium hydroxide. Now let's think how they covalent bonds with another surrounding special.
Covalent compounds are a little different, you see. Covalent compounds are composed of two nonmetals and are named with prefixes. The prefix indicates the subscript in the formula, which is essential for a covalent compound. You must remember that the second element always gets a prefix. Here, let me explain a little bit more. We have the compound carbon monoxide, which may sound pretty familiar. It is a toxic gas that may kill you if consumed in concentrations above about 35 ppm. Its formula is CO. So remember, say no to CO. Lastly, we have CiCO2, which is silicon dichloride. Silicon is found in liquid slugs, and chlorine is found in everyday swimming pools. Due to both elements being nonmetals, we are on the right-hand side of the periodic table. Which are on the right-hand side of the periodic table, we form silicon dichloride. Well, that's all for today, folks. Hope you enjoyed the short lesson on nomenclature for ionic and covalent compounds. For the crew of trying to survive chemistry and we're signing off, hoping you too can survive the world of chemistry.
That can be right. Let me get this little snack.
So since it has a negative charge, 2 and nitrogen has negative charge, the bond of the opposite element. So say you have an element on the periodic table, it's how many electrons can be gained in the particle.
You expect me to be kind of.
I am the common fly.
So let's make it a better job of you can get it become perfect.
Oh! Okay, so we're writing down like the and here we're exciting. So like whenever we say how would this video we can do it here. It's like Zoom. Any of this stuff. time sharing. You know, Alright, so we'll put you in the
Say, I want to get calculated to all my,
Okay, so. So tell me. Okay, ready, set, go. What do you think? Everyone took a seat. We're learning about nomenclature today.
Is that what we need?
Very good, Gia. Let me start with some background information for the students who do not know as much about chemistry. Ions are elements on the periodic table that either gain or lose one. They only fill their last symbol. Yes. If an element gains an electron, its charge is negative. If it loses an electron, its charge is positive. These are changes for the anchors on the periodic of elements. These transition metals are V groups due to their own unique yes, there are ionic and covalent bonds. Ionic bonds are two metals directly nuclear and non-nuclear, and are expressed in the formula U. Atoms and ionic bonds either gain or lose electrons. You got it. Positive and negative.
Well, okay, you were gonna get that, and then it's my focus on
And are solid at room temperature with very high voltage.
wow.
Ionic bonds are very brittle.
So I feel and I have to go on Wednesday, and I have practice again after school today. So the dress was not good.
The other type of bond is covalent, and it doesn't involve atoms because atoms and covalent bonds share electrons. They are between two non-metals, and they are shaped like a bond, like H2S. That's correct. That means that they have a very low melting point and are also not soluble in water and not conducting at all. Let's practice a few examples. Ionic bonds can either be binary or ternary. Who knows what that means? Fire today. Let me show you this first. This element is on IgE. It's straight from the periodic table. And since AgE is a polyatomic ion, you will see IgE. This just means there's one less oxygen atom. Gene, please pick two elements to be our first binary example.
Yes.
Very good. Okay, so the name of this bond is francium selenide. To turn this into the formula, we must look at the charges and use the crisscross method. Anyone tell me the charges themselves? Gia?
So the hydrogen and no.
You're just kidding. Yes, now we crisscross the charges and write them as subscripts. Side by side. SR2SE. Do not put the one. Let's try another example. Gia, how would you change this formula to use S? If both elements have a charge of 2 plus or minus. Roman numerals always come in handy. Okay, let's move on to ternary ionic bonds. Gia, give me a metal and a polyatomic ion with charge. Okay, rubidium and RB is carbonate CO3. So just for the charge, you got RB2 is CO3. First of all, when you use those parentheses, really, it's yellow, hypochlorite. So you tell me. You are a star student. Okay, so the middle are locked. Subject rules are the same. If there are no atoms, you don't have to worry about these numbers. After the D is pretty simple. And to the beginning of both words, depending on what you put the formula. Again, because phosphorus 3 and carbon 2 are both non-metals. Tri is 3, and then di is 2, so we try phosphorus 5.
That's so easy. I got it.
whoa, not so fast. There's another rule I forgot to mention. See, chlorine sodium sulfide, for example, formula for this is Good catch, but no. You said the prefix mono at the beginning of the first word. Mutilating it last time because I want you all to have a little more.
I took away.
Okay, everybody back in my room, please. People in 5, 4, 3, hush, 2, 1. Thank you. Okay, so we have about 30 minutes left. I have some groups I still need to do, but we have groups that were playing, so it's fast, but we also need to talk about options and nomenclature. Please go back to see Does everybody have this at their desk? Pass it back to the front. Oh, okay.
I saw that too. That's what I did.
So I think what you need to do is just get another class and get on it.
Yeah.
Okay, guys, raise your hand if you did not get a paper. Okay. I think you're back on track with me, so that's a good change of pace. I got to see some really cool stuff. So what we need to do now is think about videos. Videos maybe can be within 24 hours. That would be great. That means that if you need to, my Wi-Fi unit stops right now. So and I'm trying to complain to school and get that fixed because we use that a lot. If you can send it to me, either by uploading it to YouTube and then sending me the link, making it public, not private, that's probably your best option. If not, you have to send it in multiple files to me on MP4, or you can connect your phone to your computer, download the files to your computer, and send it to me that way. It actually works with the email easier. You can email it to me any way you possibly can. Yeah, that'd be great. And if you can't, then no, Sally does not let me accept videos. It just now has got me on pictures, so I'm happy with that. I can't ask for too much. Okay, so we're going to switch modes and go to acid nomenclature. This is the last bit of problem set 9. It's the last bit of problem set 9 that you do not know. And it's pretty, there's only 2 ways to do it, but I need to give you quite a few examples so you kind of get the hang of it, okay? So, first step, acids all contain H+. Okay? H+ actually is the defining feature of an acid. This is, you can write on the bottom of the acid notes, or you can write on the back of your foldable. You can write it on your arm. I don't care where you write it. Write it someplace, okay? So it all contains an acidic hydrogen, which is just an H+. It also is going to be bound to something else, okay? That something else can be either just simply a nonmetal, or it can be a polyatomic ion. That's it. There's only 2 options. And I don't know if you noticed, there's a plus sign there. So actually, acids act ionically. They act ionically because they actually are bound together and crisscross charges, just like ionic bonds do, okay? So you must crisscross charges, just like ionic. I'll give you a second to catch up, because there's a little outline here of what we're going to talk about. Okay, so our first easy form of acid is something that you're probably familiar with. For example, hydrochloric acid. Who's heard of hydrochloric acid? Okay, that word hydro does not mean H. Okay, so a lot of times you're like, oh, hydro, and then there's an H here. Yeah, hydro means H. Hydro does not mean H. Every single acid has an H in it, so that can't be like what that prefix means. Hydro actually means binary. Okay, hydro means it's a binary acid. What does binary mean again? 2. It's H with one other element, one nonmetal. So if I said hydrochloric, what nonmetal is it speaking of? Chloric sounds like chlorine, right? So that would be HCl. Now, I just went ahead and told you the full formula, but we would actually have to derive that ourselves by finding the charges. So what charge is H again? Right there, 1 plus, right? What charge is chlorine based on the periodic table? Why -1? So I'm going to say group 7A, so it's 1 away from noble gas, right? So that means it's going to gain 1 electron, giving it a 1 negative charge. Okay, so you crisscross those, you get 1 and 1, but 1's look dumb, so we just don't write them. Cool? Okay, so that's how you get hydrochloric acid. What if I said instead hydrophosphoric acid? So let me write that up here. Hydrophosphoric acid. What nonmetal is it describing?
Phosphorus.
Phosphorus, right? So hydrophosphoric acid has an H plus in the front. What's the back? What's the anion? P what? I3 minus. It's in group 5A. And I lost my, there's my clicker. I'm going to point over here actually. So phosphorus is in group 5. So 1, 2, 3 bounces over to it looks like argon's electron configuration. So it gains 3 electrons, so it gets a -3 charge. So crisscross, what do you get for its full formula? H3P. Good. Okay, so these are supposed to be simple because they're just binary, H plus and then a nonmetal. The ones that are a little bit more complex are things like, who's heard of sulfuric acid, phosphoric acid, carbonic acid, acetic acid? What are you not hearing? Hydro, because it's not binary, right? Is it still an acid? Does it still have an H plus? Yep, sure does. It still has an H plus with a poly ion, okay? It's going to have something big there. Now, what I'm saying, though, actually does kind of tell you the polyatomic ion if you can read between the lines, okay? So sulfuric acid is telling you the polyatomic ion sulfate. Okay, so what did I do to the sulfate to put it into acid name? I dropped the N and did what? I dropped the 8 and added an ick. Okay, we love ick in terms of ick acid. You only heard ick acid, like hydrofluoric acid, hydrochloric acid, hydrosulfuric acid, hydrophosphoric acid. All the ick acids are always present in binary, but only sometimes when you're talking a ternary acid or a big acid. So sulfate goes to sulfuric. So here's my cheesy way. I know you guys love my little stupid ways to remember these things. Ick, I ate too much. Okay, somebody told me that years ago, and I've stuck with it because it just makes sense. Ick, I ate too much, okay? So if you got something better, bring it on, because I've been using that for 5 years. I need something else. All right, so sulfuric acid came from sulfate. Okay, tell me what sulfate's formula is. Sulfate. I hear some people doing it from memory. SO4 what? 2 minus, and then what is it? What are all acids bound with? H1 plus, right? So crisscross, what do you get? H2SO4. That is sulfuric acid. H2SO4. And I'm going to try to keep putting parentheses there so you can see that it's still sulfate. All right, so that's sulfuric acid. I'm going to change the name just a little bit and call it sulfurous acid. Okay, so I've only changed the ending to indicate that it actually is not sulfate anymore that's involved. It is something else. Sulfite. What is sulfite? You should not even have to look at your period or polyatomic ion list. Not for this one, if we just did sulfate.
It's -1.
-1 O, so instead of SO4, it's SO3, 2 minus. And what is it bound with? H plus, so what's the formula? Right, you're crisscrossing H2SO3. Okay, so that right there, H2SO3 is sulfurous acid. That up there is sulfuric acid. Do you realize that, like, we have to be very deliberate about what we're saying now, because it's not like, much like bromine. No, it's like bromide. So we just gotta pay attention. Okay, so here's my new cheesy saying. This one is not exactly, I mean, it makes sense. Ick, I ate too much, I got a tummy ache. Now I've got tendinitis. Tendinitis. Itis. Tendinitis. Just. Okay. Yeah, if you got something better, bring it on, okay? So, ate to ick, I ate too much. Ite to os, tendinitis. That's all I got for you. That's not how you spell tendinitis, by the way. Don't spell in like anatomy like that. That's not how you spell it. Okay, so knowing these two different ways of naming acids, let's try some, and they're on your paper, okay? So I see a couple people still writing down my like cheesy ways here. Cheesy is the way to go. Okay, so let's start on. Let's start looking for ones that say hydro. So looking right here, you see hydrobromic acid. What does hydro mean again? Binary. So it's H with what in this case? Work with me. Work with me. Write down these examples. If not, you're not going to do your homework. So there's H plus and what nonmetal? Bromine. I hear you. What's the charge of that? What's the charge? -1. Okay, so H plus, bromine 1 minus, crisscross. What's the formula? HBr. I know I'm writing that here, but I'm only going to do a couple of these examples for you. Okay, tell me one on this side that's going to start with hydro. No. I see 18. We already did that example though, so go down a couple more. 21. HI. How do I know it starts with hydro? No. It is binary. Everything starts with an H, but you don't hear me saying hydro, right? Everything starts with H. That's the deal with acids. But it starts with hydro because it's a binary acid. It's just 1, 2. So how would I change iodine to fit acid name? Iodic. Sounds weird? Iodic acid. Hydroiodic acid. Because it's not iodine, it's iodic acid. Okay. Tell me another one. How about 23? Start me off. Hydro. And then change the ending? Chloric acid. And then 30 I already did, yeah. So hydros are only the binary ones. So if you see hydro, you write H with one element. If you don't see hydro, you're looking for things that are just an H with one element. Like H and F here, or I and F here. So these other ones, that means that they are not going to say hydro, right? So don't even think hydro. This right here, nitric acid, nitric came from nitrate. Okay, so what's nitrate? NO3 charge, 1 minus. That with H plus makes what formula? HNO3. There you go. That is nitric acid. HNO3. Nitric acid. So I just did number 1 here. So look for another one that is ending in ick so we can go to its 8 form. 14. So carbonic acid. Carbonic came from carbonate. So what's carbonate? CO3 charge. 2 minus. Okay, so if you don't know these, you need to be looking at the polyatomic ion list like every second, okay? H plus, H1 plus, right? Okay, crisscross, what do you get? H2CO3. And this is what's found in soda. Carbonic acid, bubbly. Okay, so there's our carbonic acid. I'm actually going to go back up and show you this. We just did nitric acid and that was nitrate. So then tell me how that's different from number 9. That's nitrous acid. So it's not nitrate, it's nitrite. So that's tendinitis. So NO2, 1 minus. How can you do that automatically from number 1 down here to number 9 without even looking at the periodic table? I mean the polyatomic ion list. Right, so 8s have this, in this particular 8 version, it has O3. And the ite version of nitrate, you drop an O, so it's nitrite with NO2. And then you still have your H plus. Okay, so what does that make when you put it together? HNO2 for nitrous acid. Okay, let's go over here. That let's do the second one. H3PO4. What polyatomic do you see? So you see PO4. PO4 3 minus maybe, because you see that 3 right there. So that's phosphate. So you're looking at polyatomic ion list. That's phosphate. So how do you change the name? Phosphate goes to phosphic, but it's phosphoric. Yeah. So phosphate kind of sounds weird, so it's phosphoric acid. And it's okay if you mess up one of the syllables, as long as the ending's right. I kind of get what you're saying. Phosphoric acid. How about 25? HClO3. What polyatomic ion do you see in that? Do you see the ClO3? ClO3 is chlorate. Change it. Chloric. That's ick. I ate too much, right? Ick and ate go together. Chloric acid. So chloric acid is HClO3. What about 28? Without even looking at the polyatomic ion list. 28 is HClO2. Chlorus. Good. Because that is our ClO2, which is one down from ClO3, so it went from chlorate to chloric, which is chlorus acid. It's like a mind game. You got to work on these. These you can kind of, there's too many prefixes or suffixes to worry about, so you just have to kind of practice. And then let's go big boy, number 16. So I just went HClO3, going down to HClO2. Now I'm going back up here to HClO4. What was that weird prefix you added if you added an oxygen? Only did it once. Chloric acid. Per means to like plus one. Per plus one. P. There we go. Per plus one. Perchloric acid. Okay. I think I've done enough examples. If you guys want to practice more on acids, that is now. We have about 20 minutes left. If you need to ask me questions on problem set 9, now is the time as well. I had some I was going to do, but I'd rather you ask me the ones that you need. So I'll just come around. You guys can work together. You have 20 minutes left in class. Get some of that problem set 9 taken care of. Is that okay? Yes. Good? Yeah. I'm coming to you.
Yeah, that's what I'm saying. This is like different because I don't get that vibe.